Hi there, we are FTC Team 24751, Green Am's Robotics team, and welcome back to our series FTC 101. This is the second video of our FTC Mechanics 101 series, and today's video is FTC 101 Common Materials. Now, let's get right into the video. When making a robot, you should know which materials to use for different situations, whether pre-made parts or custom parts. To choose a material, you need to judge it based on a few factors. Based on our experiences, there are three main qualities that most teams look for in a material: weight, strength, and cost. I think weight and cost are quite self-explanatory, so I won't go into detail. But what do we mean by strength?
Strength refers to how well the material performs under stress and strain, how much weight it can bear, and how durable it is. For example, if you have a part that needs to handle high loads, you would need to choose a material with high strength. Or when the load is lower, you might consider sacrificing some strength for a lighter material.
These are some common materials used in FTC. First, there are metals. Metals are prevalent at FTC and are easy to use because pre-made parts such as extrusions, channels, angles, bearings, etc. are readily available. The two main metals that teams use are aluminum and steel. Next, there are plastics, which are common for custom parts. A few common plastics are polycarbonate, ABS, acetal, HDPE, and acrylic. There are also special plastics for 3D printing, which are called filaments. This here. Then there's wood, which is not as common but could still be used in some situations. The most common type of wood for robotics is plywood, which I'm holding here, and MDF, which is a furniture grade wood.
Now let's rank this material by weight. The lighter, the better. Plastic would rank the highest because they are the lightest. There isn't much difference between the weight of different plastic, so I will group them together. Plywood would rank second, aluminum third, and steel last. Steel is significantly heavier than aluminum, so it should only be used when you really need it in order to avoid your robot being too heavy.
When it comes to strength, steel would be the strongest. Steel makes up for its weight with its strength, which is why it is used in shops and gearboxes that must withstand heavy loads and stress. However, in most situations, the trade-off is not worth it, as aluminum, while not structurally weak, is still relatively light compared to steel. Aluminum is also the second strongest among the listed materials, being able to be used for practically any part of the robot. And plastic would rank third, with polycarbonate and Delrin being slightly better at handling loads than others, making it ideal for dry chain plates and intake or outtake boxes. However, acrylic is pretty different as it can handle load but cannot absorb impact well and can easily crack. Fourth is plywood, which can be good for prototypes at a cheap option, but it does not bear load very well and can flex too much, making it unsuitable for the final product.
While making a robot, you also need to consider the cost, especially for teams on a budget. The cheapest material would be filament, which can be bought in long-lasting and refillable spool, keeping the total cost low. Next will be plywood. Plywood low price make it an incredible material for prototyping. Flat thick sheets are usually cheaper than metal sheet because material and manufacturing price are lower. Metal used in FTC are also usually pre-made, making them more expensive. So, rank fourth would be aluminum and last would be steel, due to its high cost.
However, don't rely solely on these rankings to judge the materials, as there are other important features, or X factors as I like to call them, that only some materials have. For example, filaments aren't very strong, but are light and cheap. The most important feature of filaments is that they can make parts that are too complex to hand manufacture through the use of a 3D printer. Another example would be the 3D printing filament TPU, which is highly flexible and elastic, similar to rubber, making it shock absorbent and useful for scenarios such as making a 3D printed intake roller.
To sum up, here is a table with all the ranking and property. In the next video, we will talk about how to using handheld tools and machine to shape your parts. That's it for today's video. See you in the next FTC 101 video, and good luck on the battlefield.